June 15, 1943. A courier stepped through the double doors of the Army Air Force headquarters in Washington, carrying a sealed envelope stamped top secret. He placed it on the desk of General Henry Hap Arnold, the man responsible for the entire Army Air Forces. Inside were a few blurry photographs, black and white, taken at great distance, but the images told a story that made Arnold's pulse tighten. The Germans had done it. They had built a jet fighter. The photographs showed a strange-looking aircraft with thin, swept wings and no visible propellers. The accompanying report identified it as the Messerschmitt Me 262, the world's first operational jet-powered fighter. According to the intelligence briefing, it had already completed test flights reaching speeds above 540 miles per hour. That was at least 100 miles faster than any fighter in American service. Arnold knew exactly what that meant. In a sky where speed meant survival, this machine could annihilate Allied bombers and fighters before they even had a chance to react. He flipped through the rest of the dossier. The conclusion was grim. Estimated time to operational readiness less than 12 months. The United States had no jet aircraft, not even a prototype, not even an engine. Arnold leaned back in his chair, tapping a finger against the armrest. American pilots were already dying in propeller-driven planes that struggled to hit 450 miles per hour. Against a fleet of German jets, they wouldn't stand a chance. The general didn't hesitate. He reached for the phone and barked a single order to his adjutant. "Get me right field. I need someone who can build us a jet fighter fast." The engineers at Wright Field in Ohio didn't sugarcoat their reply. "Sir, we don't have the technology. We're years behind Germany. Designing a jet from scratch would take at least 3 years. It can't be done." Arnold's voice cut through the static like a blade. "Then find me someone who doesn't know it's impossible." 3,000 miles away in Burbank, California, that someone already existed. Clarence Leonard Kelly Johnson was 33 years old, a quiet, intense engineer with the kind of mind that saw the world not in shapes or colors, but in forces and airflow. To him, steel and air were partners in conversation. He could glance at a model airplane and feel where the turbulence would twist, where the stress would snap. It wasn't intuition, it was an instinct sharpened by endless nights of calculations. Johnson had grown up in the mining town of Ishpeming, Michigan, the 7th of 9 children in a Swedish immigrant family so poor that he often walked to school barefoot in the snow. His father worked the iron mines, his mother stretched meals from whatever she could. But even as a child, Kelly's obsession was flight. He built wooden gliders from scraps, then sketched imaginary aircraft in his notebooks, dreaming of the day he could build one that defied the wind entirely. By the early 1940s, Johnson was Lockheed's chief research engineer, the man behind the sleek, twin-boomed P-38 Lightning that was carving its legend over the Pacific. But while his superiors focused on perfecting propeller planes, Johnson had already glimpsed the future. Deep down, he knew the era of propellers was ending. Back in 1939, one of his colleagues, Nathan Price, had designed a revolutionary concept, a jet engine that compressed air and ignited it for thrust, the L-133 project. It was decades ahead of its time, a design so radical it looked like something from science fiction. The War Department saw it differently. Unnecessary. The propeller works fine. By 1941, a directive arrived ordering Lockheed to stop all research related to jet propulsion. Cease immediately. Focus on P-38 production. No exceptions. Johnson obeyed, at least officially. He cleared his desks, locked away the jet blueprints, and said nothing. But when the factory lights dimmed and the shift whistles went silent, he went home, opened his personal notebooks, and kept drawing. Alone in his study, he filled page after page with calculations for air compression ratios, wing angles, and fuselage stress tolerances. He wasn't supposed to. He knew it was illegal. But something in him couldn't stop. He was designing the aircraft the future would demand, even if no one else saw it yet. By mid-1943, his secret work had filled entire drawers. When news reached Lockheed of the German jet, the phone rang in the Burbank engineering office. The military wanted to know whether the company had any designs, any at all, that could form the basis of an American jet fighter. Officially, the answer was no. But Hall Hibbard, Lockheed's vice president of engineering, knew better. He called Johnson into his office. "Kelly," Hibbard asked carefully, "do you still have those notes you weren't supposed to have?" Johnson gave a small, unapologetic smile and opened a drawer. Out came 3 thick notebooks, filled with hand-drawn blueprints and equations. He flipped them open to reveal the sleek outline of a single-engine jet with straight wings and a compact fuselage. The engine, he explained, could be adapted from the British de Havilland Goblin design. The structure could be built using standard materials, no exotic alloys, no delays. Hibbard studied the sketches for nearly 2 hours before closing the cover. How long would it take to build this? 6 months, Johnson said simply. Hibbard didn't laugh. He picked up the phone and called General Arnold's office. Lockheed can build your jet fighter in 6 months. The response on the other end was disbelief. That's impossible. No one's ever built a jet from scratch that fast. Hibbard looked at Kelly Johnson, who stood quietly in the corner, eyes steady, as though he were already seeing the finished plane in his mind. Send someone to review the designs, Hibbard said. You'll see. 6 days later, Colonel Ralph Swafford landed in Burbank. He expected vague sketches and optimistic talk. Instead, Johnson laid out complete engineering blueprints on the table, structural load diagrams, stress tests, performance projections, and even proposed assembly sequences. Every number, every angle, every rivet was already accounted for. How long have you been working on this? Swafford asked, stunned. 2 years, Johnson replied without hesitation. 2 years. You were ordered to stop. I was ordered to stop Lockheed's jet research, Johnson said evenly. I continued my own. Swafford leaned over the drawings again. The audacity was breathtaking, yet the math checked out. The design was practical, efficient, and astonishingly simple. If this could really be built, it might close the gap with Germany. Swafford looked up. If you can do it in 180 days, we'll take it. But can you? Johnson didn't blink. Give me 23 engineers, 30 mechanics, and full authority. No oversight committees, no reports, no interference. I answer only to you. We'll have your prototype in 150 days. Swafford frowned. You're cutting your own deadline. I'm motivated, Johnson said quietly. It was madness. It was also the only option left. The two men shook hands, no contract, no signature, no paperwork. Just a handshake that would launch one of the most extraordinary engineering stories in history. Kelly Johnson had just promised to design and build America's first jet fighter in less than 5 months. The morning after that handshake, Kelly Johnson walked through the Lockheed plant with a purpose few had ever seen before. The main factory floor was packed with assembly lines producing P-38 Lightnings for the war effort. Every inch of space was spoken for. No one had room or time for a secret jet project. So Johnson did what he always did when faced with a wall. He walked around it. He found an empty patch of pavement behind the main building, wedged between a storage shed and a plastics factory whose fumes could melt paint off a car. The air reeked of heated resin and industrial glue. It was filthy, loud, and miserable, which, to Johnson, made it perfect. The worse the smell, the fewer bureaucrats would visit. He ordered a surplus circus tent 60 feet by 100 and had it erected right there on the lot. A handful of benches, work tables, and drafting boards followed. The tent leaked when it rained, baked in the California sun, and rattled when the nearby factory's machines fired up. It was no one's idea of a laboratory, but for Kelly Johnson, this was holy ground. He gathered 23 engineers and 30 mechanics from across Lockheed. Most of them were young, bold minds who'd proven themselves on the P-38 project. Johnson's invitation was short and blunt. We're building America's first jet fighter in 150 days. We'll work 6 days a week, 10 hours a day. No overtime pay. If we fail, we all get fired. Who's in? Every hand went up. From the first day, Johnson set a tone unlike anything in corporate America. He called it direct responsibility. There would be no layers of approval, no endless meetings, no sign-offs from departments that didn't exist. If an engineer spotted a problem, they fixed it. If a part didn't fit, the mechanic changed it on the spot. There was no waiting for permission, because permission had already been granted. Johnson's first commandment was simple. Be fast. Be right. Don't ask. Each team member had full authority in their domain, but one rule stood above all: results. Every decision had to move the airplane closer to flight. Bureaucracy was the enemy. The conditions were brutal. Inside the tent, the smell from the plastics factory made their eyes water. The heat rose above 100 degrees by midday. When it rained, they covered blueprints with raincoats and worked through puddles. But nobody complained. In fact, they loved it. The tent gave them something that the polished halls of corporate America never could: freedom. The tent quickly earned a nickname. One of the engineers, a joker named Irv Culver, answered the phone one day and said, "Skunk Works, inside man Culver speaking," a reference to a running gag in the Lil Abner comic strip. The name stuck, though the spelling changed later to Skunk Works. It was meant as a joke, but in time it would become a badge of honor, a symbol of rebellion done right. That filthy tent would become the birthplace of the most secret and advanced aircraft America would ever build. But in 1943, it was just a canvas shelter filled with oil stains, cigarette smoke, and a dream. The first challenge was immediate and catastrophic. They didn't have an engine. The entire design depended on the British de Havilland Goblin turbojet, which was still being shipped across the Atlantic and could easily be lost to German submarines. Johnson had only the blueprints and rough measurements. To most engineers, this would be a deal breaker, but Johnson wasn't most engineers. He sat at his drafting board, rolled up his sleeves, and began to calculate by hand. Using airflow equations and structural stress tables, he designed the entire fuselage and mounting system based solely on the engine's dimensions from paper. He built flexibility into the design, leaving space for adjustment once the real engines arrived. When the first Goblin engine finally showed up in August, weeks behind schedule, the crew held their breath as it was lowered into the fuselage. To everyone's shock, it fit perfectly. The tent erupted in cheers. The second challenge came soon after. Nobody knew how a jet aircraft should behave. The XB-80 wasn't a modification of an existing plane, it was something entirely new. Every system had to be invented. Airflow, intake geometry, fuel pressure, cooling, all of it was uncharted territory. To make matters worse, the prototype had to be light, strong, and stable at speeds no American plane had ever reached. If one calculation was wrong, the entire aircraft could disintegrate in flight. So Johnson adopted an approach unheard of in military manufacturing: continuous experimentation. Instead of building a full prototype, testing it, and then redesigning, his team worked in overlapping cycles. They built small sections, tested them, refined them, and moved forward. If a part failed, they didn't write a report. They fixed it within hours. The process was messy, chaotic, and incredibly fast. In traditional programs, dozens of committees would have reviewed each component. In Johnson's tent, the engineer who built it made the decision. By late August, they had an aircraft taking shape: a narrow, elegant fuselage with straight wings and air intakes near the roots. Its skin gleamed like polished silver under the California sun. It was starting to look real. Then disaster struck. During a ground engine test, the air intakes buckled inward under pressure, collapsing like soda cans. The implosion sent shrapnel into the engine, destroying it instantly. Everyone froze. They only had 2 engines from Britain, now one was gone. There were no spares, no replacements, no time. Most engineers would have stopped the project right there. Johnson didn't even go home. He spent the next 36 hours straight redesigning the intake ducts by hand, reinforcing them with lightweight supports that maintained aerodynamic shape but prevented collapse. There was no chance to test his new design. If the fix didn't work, the second engine would be destroyed too, and the program would die. They installed the remaining engine, tightened every bolt, and ran it again. The jet screamed to life, shaking the tent walls. Johnson stood by, expressionless, as the team throttled up to full power. The new ducts held perfectly. For a brief moment, over the deafening roar of the jet, everyone in that tent realized they had just witnessed history. The United States finally had a working jet fighter. But time was running out. By October, they were still weeks behind schedule. The deadline was immovable. Johnson refused to quit. He ordered 7-day work weeks and personally worked 16-hour days, solving problems in real time. He moved from station to station, welding here, sketching there, making split-second decisions that would normally take weeks of review. The tent became a living organism, a heartbeat of tools, hammers, sparks, and coffee-fueled minds chasing an impossible dream. On November 8, 1943, after 143 days of non-stop work, the XB-80 nicknamed Lulu Belle rolled out into the sunlight. It was sleek, smooth, and beautiful. They were 8 days late by their own target, but still a week ahead of the militaries. As the workers stood back and looked at their creation, exhausted and covered in grease, Johnson said quietly, "Gentlemen, we just built the future." The desert sun was already burning when trucks from Lockheed arrived at Muroc Army Airfield, a stretch of dry lakebed in the Mojave Desert known for its endless horizon and brutal heat. The XP-80 prototype, Lulu Bell, rested on the flatbed trailer beneath a tarp. Even covered, the aircraft looked alive, its silver skin catching flashes of light as if it were impatient to fly. The team unloaded the jet and rolled it into a small hangar. For weeks they had lived inside a tent that reeked of chemicals. Now they stood under open sky, their creation finally free. Kelly Johnson walked around the plane slowly, his hand gliding across the smooth aluminum. For him, this wasn't just metal and rivets, it was proof that determination could beat bureaucracy, that imagination could outpace rules. But the moment of pride didn't last long. The real test was still ahead. If the XP-80 failed to fly, or worse, crashed, the entire project would be shut down, and Johnson's career would end in disgrace. The man chosen to fly it was Milo Burcham, a veteran test pilot with nerves of steel and a sharp grin that hid how much risk he took each day. He had flown nearly everything Lockheed ever built, but no one in America had flown a jet before. The XP-80 wasn't just fast, it was unpredictable. As mechanics made last-minute checks, Johnson briefed him quietly beside the plane. "The controls will be very light," he said. 15-to-1 boost ratio on the ailerons. Treat them like glass. A rough hand will kill you." Burcham nodded but said nothing. He knew Johnson's calm voice meant the danger was real. The morning wind was still. The engine technicians gave a thumbs up. Burcham climbed the ladder, settled into the cockpit, and adjusted his helmet. The controls were simple: no propeller throttle, no pitch levers, just thrust. He pushed the starter button. A whine filled the air, rising higher and higher until it became a scream. The Goblin turbojet roared awake, blasting a column of heat behind it. Everyone stepped back as the ground vibrated. At exactly 10 am, Burcham released the brakes. The jet rolled forward, slowly at first, then faster: 60, 90, 120 miles per hour. The sound was unlike anything anyone had ever heard. Not the deep growl of a piston engine, but a smooth, continuous howl like a living thing. After less than 2,000 feet, Lulu Bell lifted off. For a moment, the desert world seemed to pause. Men shaded their eyes, watching the silver aircraft rise into the blue, leaving behind only a thin, shimmering trail of heat. It was the first time an American-built jet had ever flown. Johnson stood perfectly still, arms crossed, his jaw clenched. The takeoff had been smooth, but every second after that was a gamble. No one knew how a jet would behave in the sky. Would it stall? Would the heat warp the fuselage? Would the controls flutter apart? Up above, Burcham tested the ailerons. The aircraft responded too quickly. A flick of the wrist sent the plane rolling violently. He steadied it, tried again more gently, and realized the truth. The XP-80 wasn't unstable. It was too responsive. He flew for 5 minutes, barely touching the stick, then brought the jet down carefully, the wheels kissing the runway in a perfect landing. When he climbed out, he was grinning but shaking his head. "It's too sensitive," he told Johnson. "The controls need redesign." Johnson walked around the plane once, thinking. "No," he said finally. "The aircraft is fine. You're over-controlling it. This isn't a bomber. It's a new species. Treat it like one." Burcham stared at him for a moment, then smiled. "All right," he said. "Let's find out what she can do." The next morning, he flew again. This time he used only his fingertips on the stick, as if guiding a wild animal instead of commanding it. The jet responded beautifully, smooth, precise, alive. He climbed to 5,000 feet, accelerated, and looked down at the desert blurring below. He pushed the throttle forward. The aircraft trembled slightly, then stabilized. The airspeed indicator crept upward. 400 miles per hour. 450. Then, with a smooth surge, Lulu Bell broke through 500. No American pilot had ever flown that fast before. Burcham leveled off and began to laugh inside his oxygen mask. The sky around him was silent, no pistons, no vibration, just the clean, continuous rush of air. He felt like he was slicing through time itself. When he landed, Johnson met him at the runway. "How was it?" he asked. Burcham pulled off his helmet, sweat streaking his face. "She's a beauty," he said. "And she's fast. Real fast." That single flight, 502 miles per hour in level flight, officially made the XP-80 the fastest aircraft in the United States. The desert crew cheered. Some of them laughed, some cried. They'd done what everyone said was impossible. In the months that followed, further tests pushed the jet even higher. By March 1944, it was climbing to 45,000 feet, reaching speeds of 558 miles per hour, an unheard of figure at the time. The military reports were glowing. Performance exceeds all current fighter designs. Highly recommended for production. General Arnold personally visited Lockheed to see the aircraft that had once existed only as contraband drawings in a notebook. When he saw it take off, his expression said everything. "It's beautiful," he murmured, "and it's ours." He ordered immediate production of service test aircraft, 13 prototypes, followed by a contract for 1,000 fighters. America had entered the jet age. Yet beneath the triumph, an irony lingered. The official government paperwork approving the XP-80 program didn't even reach Lockheed until October 16, 1943, 4 months after Johnson's team had started and barely a month before the first plane was completed. The Army's own auditors were furious. How could millions be spent without contracts, without bidding, without signatures? Arnold's reply was short and unanswerable. They built the best fighter in America in 143 days while following no regulations. Maybe the problem isn't them. Maybe the problem is our regulations. That sentence ended the investigation. The XP-80, later redesignated the P-80 Shooting Star, missed World War II by mere months. The first combat-ready aircraft rolled out just after Germany surrendered. It never met the Me-262 in battle, but its real victory was larger than a single war. For the first time in American history, innovation had outrun bureaucracy. The Skunk Works had proven that a small, trusted team could do in months what government programs took years to accomplish. And somewhere in Burbank, under a torn circus tent that still smelled faintly of resin, Kelly Johnson smiled and began sketching again. He wasn't thinking about the past. He was already designing the future. The war ended before the Shooting Star could taste combat. When peace returned, the world was exhausted, but Kelly Johnson wasn't. The XP-80 had proven what he believed all along, that great ideas didn't come from committees or forms. They came from people who were free to think, act, and risk. While the factories around him slowed, Johnson's mind accelerated. He saw what was coming, a Cold War brewing in the shadows, where information and altitude would matter more than sheer numbers. Jet technology was still young, but he knew the next race wouldn't be about speed alone. It would be about vision. Who could see first, fly higher, and reach where no enemy radar could touch them? And so, the little circus tent that smelled like glue and gasoline became something far greater, the most secret and innovative division in American aviation history. The Skunk Works was officially born. In the years that followed, the tent gave way to a small hangar hidden behind the main Lockheed facility. No signs, no official paperwork, just an unmarked door and a handful of people who seemed to live inside it. Johnson was their leader, mentor, and sometimes their tormentor. His standards were brutal, his deadlines impossible, and his rules legendary. He called them Kelly's 14 rules. They weren't written for comfort, they were written for results. Start with small teams, he said. Give them authority, trust them completely, cut red tape until you can see daylight, and never ever let a meeting last longer than necessary. He demanded personal responsibility from everyone. If an engineer designed a part, they owned that part. If a mechanic installed a bolt, they were accountable for that bolt. Everyone was part of a living organism that moved as one mind. When government officers tried to visit and offer help, Johnson would politely turn them away. "Come back when we're finished," he'd say. "Right now, we're busy building the future." By the late 1950s, the Cold War had shifted into high gear. The Soviet Union had shot down several American reconnaissance planes, and the CIA needed a way to see deep into enemy territory from an altitude no missile could reach. Once again, Kelly Johnson raised his hand. The result was the U-2 spy plane, an aircraft so thin and graceful, it looked like a silver needle in the sky. Designed, built, and flown in less than 2 years, it could soar above 70,000 feet, photographing entire countries in a single pass. When the U-2 took flight for the first time, it climbed so high that the pilots could see the curvature of the Earth. The stars shone even at midday. It was a plane that touched the edge of space, born not in a boardroom, but in the spirit of a man who refused to wait for permission. When the U-2 was eventually shot down in 1960, Johnson took the blame personally. "We built it to do a job," he told reporters, "and it did that job." But he already had his eyes on something faster, higher, and more daring. In 1962, the Skunk Works began work on what would become Johnson's masterpiece, the SR-71 Blackbird. Even today, decades later, it looks like something that doesn't belong to this world. A spear of black titanium, stretching 107 feet, designed to outrun missiles and outfly every jet on Earth. It flew at more than 3 times the speed of sound Mach 3.2, while gliding at 85,000 feet. The friction of the air heated its surface so intensely that it glowed red hot, yet it remained undetectable to radar. No aircraft has ever surpassed it in both beauty and terror. And once again, it was built the Skunk Works way. A handful of people, impossible deadlines, and the absolute authority to make decisions without interference. When a general once asked Johnson how he expected to finish such a radical aircraft on time, he replied, "Because you're going to leave us alone." He delivered the first prototype a year early. In 1981, a new kind of challenge appeared: stealth. The Dream was an aircraft invisible to radar, capable of striking deep into enemy territory without being seen. Johnson was retired by then, but his fingerprints were still on every blueprint, every philosophy, every rule. The younger engineers who had grown up under his methods built the F-117 Nighthawk, the world's first operational stealth fighter. It was strange, angular, faceted, as if geometry itself had taken flight. Most people thought it looked too bizarre to fly, let alone fight. But when it entered service, it changed warfare forever. From the air above Iraq in 1991, the Nighthawk's shadow passed unseen over radar screens, striking with perfect precision. Johnson watched from home, older and frail, but proud. The world had caught up to the dream he'd begun in that stinking circus tent 4 decades earlier. Even after retirement, the Skunk Works kept producing marvels. The F-22 Raptor, the F-35 Lightning Roman II, the quiet drones that can cross oceans without a pilot all trace their lineage back to that philosophy born in 1943. Every engineer who joined the Skunk Works learned the same first lesson. Innovation begins where rules end. But Johnson never confused defiance with chaos. In one of his final interviews before his death in 1990, he clarified the difference. "I didn't break rules for fun," he said. "I broke them when they stopped us from solving the problem. There's a difference. You can rebel against authority and still respect excellence." He paused, then added, "If the system slows you down, the mission fails. And when the mission truly matters, you take responsibility. You don't wait for permission." Those words became the quiet creed of the Skunk Works and of innovators everywhere. Today, more than 70 years after that summer of 1943, the legend of the tent lives on. The original site in Burbank has long been demolished, but every major aerospace project from hypersonic aircraft to Mars landers still echoes Johnson's philosophy. Engineers speak his name with reverence. His portrait hangs in offices from California to Colorado, a reminder that one man's courage to break the right rules can alter the course of human progress. There are no marble statues of Kelly Johnson, no military parades, no grand speeches in his honor. Just aircraft sleek, silent, and impossibly fast whispering through the sky. They are his monuments. Before he died, a journalist asked him what the real lesson of his life was, whether it was about engineering, leadership, or innovation. Johnson smiled and shook his head. "It's about trust," he said. "Trust your people. Trust the mission. And when the rules get in the way of what's right, trust your conscience." And so, from a leaking circus tent behind a plastics factory, the Skunk Works gave the world more than airplanes. It gave us proof that even in an age of endless red tape, human imagination, when freed, can still take flight. By the late 1980s, Kelly Johnson was an old man. His white hair had thinned, his frame had shrunk, and his eyesight was fading. Yet even in retirement, his mind remained sharp as ever, still sketching designs in notebooks, still thinking about lift and drag, still worrying about what came next. He had watched the world move from propellers to jets, from aluminum wings to titanium stealth, from mechanical gauges to digital flight systems. He had outlived nearly everyone who once told him his dreams were impossible. And though his name was rarely known to the public, every pilot who ever climbed above the clouds flew under his shadow. Visitors to his modest California home often found him sitting on the porch, a cup of coffee in hand, reading technical journals or quietly watching the contrails above. When asked what he thought as he saw jets slicing through the sky, he'd smile and say, "I see freedom up there. I see proof that we can always go faster, higher, and better if we dare to try." In 1985, 5 years before his death, Johnson gave one of his final recorded interviews. The reporter, clearly in awe, asked the question that had followed him all his life. How did you do it? How did you build a jet in 143 days when everyone said it couldn't be done? Johnson leaned back and answered with the same calm certainty that had once unnerved generals and bureaucrats alike. We didn't wait for permission, he said. We just started. He went on. We proved that you don't need thousands of people or endless meetings or mountains of paperwork to make something extraordinary. You need a small group of talented people who understand the mission, who are trusted to make decisions, and who are free from interference. Give smart people those three things, and they'll build you miracles. Then he paused, as if weighing his next words carefully. But you have to take responsibility. That's the price of freedom. I broke rules that needed breaking, but I also accepted that if we failed, I'd take the fall. That's what leadership means. The journalist hesitated, then asked, So should people just ignore regulations when they believe they're right? Johnson smiled faintly. No, he said. You should understand why the rules exist. Some protect lives, some protect quality, but some only protect comfort. They exist so people can avoid risk. Those are the ones that kill innovation. The trick is knowing the difference. And when you see a rule that stops you from doing what's necessary, you have to decide what matters more, your safety or your mission. He looked out the window for a moment before adding softly, I risked my career for the P-80. If we'd failed, I'd have been finished. But I believed the mission mattered more than me. That's not rebellion. That's responsibility. History would vindicate him. The US Air Force would go on to adopt nearly every principle born in that circus tent. Smaller teams, flexible contracts, rapid prototyping, decentralized authority. The entire model of modern aerospace development from NASA's experimental aircraft to SpaceX's reusable rockets carries echoes of Kelly Johnson's fingerprints. In a sense, the Skunk Works didn't just build planes. It built a new way of thinking. Even today, decades after Johnson's death, engineers at Lockheed Martin still keep a framed copy of his 14 rules on their walls. Each rule is brutally simple. No committees. Short lines of communication. One project leader with total authority. Minimum paperwork. Maximum trust. They are reminders of how the impossible once became possible not through luck, but through conviction. In 1990, at the age of 80, Clarence Kelly Johnson passed away quietly in Burbank, the same city where his dreams had taken flight half a century earlier. The news barely made headlines, but in military bases and engineering labs around the world, people stopped to reflect. They knew. They knew that the man who once designed aircraft under a circus tent had changed the trajectory of history. After his death, tributes poured in from test pilots, generals, and presidents alike. President Ronald Reagan awarded him the Presidential Medal of Freedom, calling him the architect of American air superiority. Yet the highest praise came not from politicians, but from his own team. One of his senior engineers, Ben Rich, summed it up perfectly. Kelly didn't build airplanes. He built people who could. Today, more than 100 P-80 and F-80 shooting stars sit in museums around the world, relics of the first American jet age. Most visitors walk past them without realizing they were born from rebellion, built in a tent that smelled like burning glue, and delivered without a single signed contract. But if you stand close, if you look at the rivets and the clean lines, you can still feel what those engineers must have felt in 1943, the hum of urgency, the defiance of limits, the belief that the future could be shaped by courage alone. Every jet that followed the U-2, the SR-71, the F-117, the F-22 carries a piece of that spirit. They are the descendants of a promise made by one man who refused to wait. In one of his personal notebooks, found after his death, Johnson had written a single line across the top of a page. Rules are tools, not chains. That line became the essence of the Skunk Works philosophy. It wasn't about chaos or arrogance. It was about clarity, the understanding that systems exist to serve purpose, not the other way around. Because when rules become more important than results, innovation dies. And when people like Kelly Johnson choose to challenge those limits, the impossible becomes inevitable. More than 80 years later, the world still lives in the wake of that decision made on June 15, 1943, when General Hap Arnold picked up the phone and said, "Find me someone who doesn't know it's impossible." That someone turned out to be a barefoot boy from Michigan who once walked to school in the snow, dreaming of flight. A man who sketched jets in secret notebooks, who built America's first jet fighter in a circus tent, who taught the world that genius needs freedom, not permission. He never sought fame, only results. He never asked for applause, only trust. And when the history of flight is told, his fingerprints will always be there, invisible, but indelible on every wing that cuts through the sky. Because Kelly Johnson didn't just build airplanes, he built the future.